This horizontal boring mill is set up for production boring of sets of holes in line. Two cutters are mounted in the boring bar, which is driven by the spindle and supported by the backrest. Efficient performance here depends upon alignment of the workpiece and correct use of the boring equipment. Here, the workpiece has been set up. The next step is to mount the boring bar. A bushing must be used in the backrest to support and guide the boring bar. Clean the bushing carefully inside and out. It is good practice to protect the surface of the table with a piece of cardboard or a cloth. Clean the hole in the backrest block before inserting the bushing. Oil the hole and spread the oil around the inside surface. Install the bushing in the backrest. It's a snug fit. The bushing is held in place by a clamp. Adjust the clamp and tighten the lock screw. Oil the inside of the bushing before mounting the boring bar. To mount the boring bar, push it through the bushing until it is balanced. Clamp the block. Clean the ways and oil them before moving the backrest to the table. With the hand crank, move the backrest close to the table and clamp it. Clean the shank of the boring bar and the spindle taper. Locate the tang and seat the boring bar in the spindle taper. The boring bar is keyed to the spindle. Consult the work drawing to determine the size and position of the holes. This view shows the two lowest holes which are to be bored in line. This one and this one. The hole is bored, then counterbored. The diameter of the hole is 3.999. With a tolerance of plus half thousand. The depth of the right-hand counterbore is 1¼ inches. This face of the counterbore is 21¾ inches from this counterbore. The diameter of both counterbores is 4.375, with a tolerance of plus half thousand. This hole is counterbored to a depth of 1/16 and is 4 11/16 in diameter. Here is the workpiece on which these operations are to be performed. The outside surfaces have already been milled. The workpiece will appear this way when the 3 holes have been bored and counterbored to the specifications called for in the drawing. The holes will be rough bored with tungsten carbide boring tools. Each tool is secured in the bar by a screw with a tapered shank which fits the taper of the hole in the tool. Insert the tool in the slot and tighten the locking screw. For efficient production, both holes are bored at the same time. Select the feed recommended for the type of tool being used. In this case, it is 12 thousandths per revolution at a speed of 300 surface feet per minute. Always wear safety glasses during a cut. With the boring bar rotating, oil the bushing again. Engage the turnstile clutch and bring the tools to the work. Start the cut with hand feed, then engage the spindle feed. Take a trial cut, clear the tools, and stop the spindle. Measure the diameter of the trial cut with calipers. Remember that 25 to 30 thousandths must be left for finishing. The drawing specifies a diameter of 3.999. This hole measures 3.970, which leaves 29 thousandths for finishing. Start the machine and complete the roughing cut. When several holes are to be bored in the same workpiece, all should be rough bored first, because cuts below the scale relieve strains in the metal. This causes distortion of the holes, which will be corrected by the finishing cuts. Always clear carbide tools before stopping the spindle to avoid dulling them. Handle the cutters with a cloth. They are still hot from making the cut. Both holes must be counterbored. This hole is counterbored first because measurements are made from it for the other counterbore. A single point tool is used. Take a trial cut deep enough for measurement. The diameter measures 4.350, which is 25 thousandths undersized. The depth of the counterbore is 1 1/4 inches. The approximate depth of the cut can be estimated by counting the turns of the spindle feed hand wheel as the cut is taken. Each turn of the hand wheel moves the cutter 1/8 of an inch. When the cutter is within about 1/8 of an inch of the required depth, clear the tool and measure the cut. The depth measurement can be made with an adjustable square. The measurement indicates that there is still about 1/8 of an inch to go. Bring the tool forward so that it just touches the work. When it touches, you can feel it through the hand wheel. With the tool at this point, set the spindle hand wheel collar to 0 for a reference. Watch the hand wheel collar and feed the tool the remaining 1/8 inch. Clear the tool and measure the depth. It is 1 1/4 inches, the dimension specified in the print. Remove the counterboring tool. It is good practice to remove the scale around a bored hole. Install a facing tool that will cut slightly larger than the finished diameter of the hole. Remove only enough metal to clean up the face so that no scale remains to dull the sharp edge of the finishing tool. The procedure for counterboring and facing the other hole is similar. To set up for the next set of holes, the boring bar must be removed. Clean and oil the ways before moving the backrest. Clean chips from the boring bar before sliding it back through the bushing. The workpiece and tool can now be positioned for roughing the next set of holes. The work print indicates that the head is to be raised 3.594 to the horizontal center line. The table must be moved 3.654 to the vertical center line. To raise the head the required distance, it will be necessary to replace the present combination of end measures in the head trough. Always keep micrometers and end measures away from the working area where they might be damaged. Calculate the new combination of end measures. The overall dimension previously set up in the head dial indicator trough is 13.111. This amount, less 3.594, the distance between the center lines, must be set up in the head trough. The result is 9.517. Decimal parts of an inch are set on the barrel micrometer. In this case, it is 517 thousandths. Select a combination of end measures to total 9 inches. Install the end measures and the barrel mic in the head dial indicator trough. Now raise the head and adjust it so the dial indicator reads 0. This brings the spindle to the horizontal center line of the second set of holes. Now the table must be moved to locate the vertical center line of the hole. Here the new dimension, 3.654, is added to the end measures already in the trough because the direction of the table movement increases the opening. Adjust the barrel micrometer for the decimal which is 654 thousandths. The 3-inch end measure is replaced by a 6-inch measure for the additional 3 inches required. When the end measures are in place, move the table so the dial indicator reads 0. The center of the hole is now aligned with the spindle. The backrest is kept close to the table to give rigid support to the boring bar. Clamp the backrest block and slide the boring bar into the spindle taper. Now the second set of holes can be rough bored in line. These holes are counterbored the same way as the first set. By following these procedures, any number of holes can be machined in a workpiece. The most important consideration is to locate the center lines accurately. This can be done easily and quickly using the end measures and dial indicators which are part of the production setup of the horizontal boring mill.